Find the vertical deflection. At E of the loaded frame. Loaded frame. A is equal to 1000 mm square. X modulus E is equal to 2 into 10 power 5 mm square. 2 into 10 power 5 Newton per mm square. And the frame is given as like this. I'm giving the dimensions. This support is A. This support is actually a roller support. Please make a correction. This is roller support. This one is B. Yeah. The joint is there C. Divisions of 3 meters. Divisions of C. This is C. This is D. Joint D. Now at the joint D. Joint D. Joint E. The force of 10 kilonewtons is acting. This distance is 3 meters. So what they are asking? They are asking us to calculate what is the deflection at E. Now first what we have to see is external force 10 kilonewton is acting on the point. So we can calculate the vertical deflection at that. So before calculating the vertical deflection, let us first of all understand here this vertical deflection delta E is nothing but what is that one? 2 into U by L. 2 into U by L. What is that? Delta E. Now what is meant by U here? U is nothing but summation of E square L by. So here what is meant by P here? P is nothing but the tension or compressive force in the entire frame. So for each individual number, we have to calculate what is the force in the number, whether it is compression or tension. If it is tension, keep it as positive. If it is compression, keep it as negative. So for each and every number, we need to calculate what is the force in numbers. So you have to use either method of joints, tension coefficient method, or method of sections. The easiest way is go with method of joints. So theta is 26.56 degrees. This is also 26.56. This is also 26.5 degrees. Now go to joint E. Write down the free body diagram at joint E. So this is a joint. Here a horizontal force of force in CE is there. and this is also a force of DE is there. It is making an angle of 26.56 degrees. And a point load of 10 kilonewtons is acting. You have to resolve the force as it is inclined force. This FDE you have to resolve along x-axis. This one is FDE. Adjacent to your theta, just remember, adjacent to your theta is cos 26.56. FDE sine 26.6 degrees. Sigma fx is equal to 0 minus FDE cos 26.56 minus FCE is equal to 0. Why? Because they are going in the left side. As per sign convention, left side will be considered as negative. So minus FDE minus DE cos 26.56 minus FCE is equal to 0. From here, minus sigma Fy is equal to 0 minus FDE sine 26.56 minus 10 equal to 0. So you can tell me the value of FDE 10 by sine 26.56. Substitute this value in the equation to get FCE, and FCE will be plus 20 kilonewtons, which is under tension. So free body diagram at E is completed. We calculated what are the forces in these two members. This is done. This is done. If you go to joint C, then how many unknown forces are there? 1, 2, 3, 4. 4 members are there. 1 is known, 3 are unknown. Go to joint D. So you know that wherever you are in the joint, the number of unknowns should be less than or equal to 2. Should be less than or equal to 2. So F, B, D, H, joint D I am taking. So understand the importance of this. If you know the method of joints problem, then only you can solve this. So if you are not familiar with the method of joints, then how can you solve this? That is very, very important. In the previous unit, you should know how to solve these method of joints, method of sections, and tension coefficient method, and that will be useful to calculate the diffraction. Everything is interlinked. Draw the free body diagram. This is force in E. I am assuming every time all the forces are as tension. This is force in C. This is force in BD. Here the angle is nothing but 26.56 degrees. Now, sigma fx is equal to 0. Write down the equation. Before writing that, you resolve the forces along x-axis as well as along y-axis. This is FB. 26 is adjacent to your force, which is cos 26.56. This is FDE sine 26.56. So sigma fx is equal to 0. That is nothing but minus FBD plus FDE cos 26.56 is equal to 0. Your FDE force is nothing but minus 22.36. So minus FBD minus 22.36 cos 26.56 is equal to 0. You get the value of FBD, which is nothing but minus 20 kilonewtons under compression. Under compression. So now take sigma Fy is equal to 0. And here vertical forces plus FTE sine 26.56 plus FCD is equal to 0. So FDE value is nothing but minus 22.36 sine 26.56 plus FCD 0. We get the value of FCD. The value of FCD is nothing but 10 kilonewtons. Please do the simplification. Draw the free body diagram at joint C. Keep setting FBD at C. So when you are taking FBD at C, how many forces are there? Just observe here. See the diagram. This is one force which is going towards the force in AC. This is force in BC. Initially, I assume all are in tension. That's why away from the body I am writing. If I write like this is towards the body, which is compression. So we are assuming that away from the body. And this force is force in CE. Another force is there. This is force in CD. So this is C. Now the angle made by this one is, we have already written this, which is 26.56 degrees. This angle is 1.5. This distance is 3 meters. So you can take a tan theta is nothing but 1.5 by 3. That implies theta is nothing but tan inverse of 1.5 by 3, which is indicative of 26.56 degrees, which we have already calculated in the last class step. Now 26.56 degrees. 26.56 is also the same for the PC member. Now resolve the forces along x-axis as well as along y-axis. So this AC force, you have to write down this FAC cos 26.56. This is FAC sine 26.56. Whereas coming to BC force is nothing but FBC cos 26.56, FBC sine 26.56. Now sigma Fx is equal to 0. So calculate the horizontal forces along x-axis. This is there, this is there. FCE is there. So FAC cos 26.56, which is negative. Remember here, this should also be considered minus FAC. Why? Because and that is going towards the left side, minus FAC cos 26.56 minus FBC cos 26.56 plus FCE is equal to 0. So what is the value of this one? FCE, we have already got the value of FCE.
20 kilonewtons, sir.
20 kilonewtons, that is plus 10. Can any one of you tell me what is cos 26.56? Cos 26, okay, we'll take FAC plus FBC is equal to FCE by cos 26.56. So here the value of FCE, you just told it as 20. So 20 by cos 26.56 is 22.35 kilonewtons. Now write down sigma Fy is equal to 0 plus FAC sine 26.56 minus, why? Because this is positive. Yeah.
Sir, FCE value minus 20, sir.
FCE minus 20 or plus 20, ma? It is showing it as FCE plus 20 tension. So this will be plus 20. So just see the equation. How it will be changed is minus FAC cos 26.5C minus FBC cos 26.56 is equal to minus FCE is equal to minus FCE. What I did is entire minus up in the equation is cancelled. This cos 26.56 is taken common, which is sent towards the right side. That's why you got this equation, which is positive only. Why? Because minus 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 will be cancelled. So FAC cos 26.56 plus FBC cos 26.56 is equal to FCE. Cos you can take common and you can send it to the FCE by cos 26.56. Did you understand, Pujita?
Okay, sir.
Now, go to the sigma Fy equation. FAC sine 26.56, it is going in the upward direction, minus FCD minus FBC sine 26.56 equal to 0. FCD is 10. Here it is looking. So FCD is 10. Substitute that value. FAC sine 26.56 minus 10 minus FBC sine 26.56 equal to 0. Sine 26.56 just minus 10, you can send it towards right side 10, and this is FAC minus FBC. Sine 26.56 you can take common, 10 by sine 26.56. FAC plus FBC is equal to 22.35. FAC minus FBC is equal to 22.36. So adding both, you will get 2 times of FAC is nothing but 44.71, whereas FAC is nothing but 22.36. So as FAC is 22.36 at 355, you will get it. Whatever the value, just round it off to 22.36 kilonewtons, which is positive, and that is indication of tension. So substitute in the above equation from 2, what is happening is FBC is equal to 0. Here there are 6 members are there. We will write down each member, then length of the member, force in each member. In our method of joints, we use it to write it as the magnitude of the force as well as nature of the force. But here, our idea is to calculate the deflection. I will mention it as force only, along with force. Now I will write it as AE. That is nothing but axial rigidity. A multiplied with E. Then P square L by 2A. Just to see what I am going to do. I will give you a time. Please listen first of all. Please listen. No need to write. Here member AC is there. BC is there. PD, CD, CE as well as DE. All of you just to see the diagram of our frame given. This is the frame given for us. I will copy this frame. Yes. See this one. Here the length is 3 meters. This is 1.5 meters. What is the length of this one? BC. So to get the length of BC, you need to take it as a square root of 1.5 square plus 3 square. What is that value? As this is 3 meters, this is 1.5. So this is hypotenuse square root of 1.5 square plus 3 square. This is 1.5 meters. This is 3. This is also 1.5 square plus 3 square.
3.35 meters, sir.
So 3.354 meters. Accurately, we'll write down up to 3 decimals. 3 decimals. So this is 3.354 meters. This is also 3.354 meters. Now enter the value there. The length AC is 3.354 meters. This is BC also 3.354. BD. What is the length of BD? BD is nothing but from here to here 3 meters. So substitute that value there. BD is 3 meters. CD. CD is the vertical height, which is 1.5. CE is 3. DE. DE is 3.354 meters. So you got member, length, force. Now coming to the force. Yes, we calculated just now. I will represent this as capital P. And if this is positive, mention it as positive for tension force. And we will enter the values AC plus 22.36, BC 0, BD value minus 20, CD is 10, so minus 20, 10. See the units, they are in kilonewtons. CE, what is the force in CE? Plus 20. What is the force in DE? Minus 22.36. Minus 22.36. Just it is calculated above. CE is plus 20, DE is minus 22.36 kilonewtons. Now I asked you to calculate AE also. Just to see the units given for A. A is in 1000 mm square. E is 2 into 10 power 5 Newton per mm square. 2 into 10 power 5 Newton per mm square. Okay. So just go back to our table. Go back to our table. Member length force is calculated here. A is mentioned as 1000 mm square. E is mentioned as 2 into 10 power 5 Newton per mm square. So 2 into 10 power 5 Newton per mm square. Just A into E is nothing but 2 into 10 power 5 multiplied with 1000, which is nothing but 2 into 10 power 8. Now understand here, what is the unit of axial rigidity? This is Newton per mm square into mm square, which is nothing but the unit is Newton. So AE, axial rigidity AE is 2 into 10 power 8 newtons. Just understand here, force is in kilonewtons. That's why it should also be in kilonewtons. 2 into 10 power 8 by 1000 kilonewtons. So 2 by 1000. Why? Because 1 kilonewton is 1 by 1000. 1 newton is nothing but 1 by 1000 kilonewtons, which is 2 into 10 power 5 kilonewtons. And substitute the value of AE, 2 into 10 power 5. 2 into 10 power 5. What are the units of this AE? Axial rigidity is in kilonewtons. Just see once again. A is 1000 mm square. E is 2 into 10 power 5 Newton per mm square. To get the value of axial rigidity AE, multiply both of them. This is in terms of Newton per mm square. into mm square. So this mm square is cancelled and the answer is Newton. So 2 into 10 power 8 newtons. And you have to divide it by 1000, which is 2 into 10 power 5 kilonewtons. So 2 into 10 power 5, 2 into 10 power 5, 10 power 5. Now you already know p square into L by 2AE is nothing but that is just multiply p square into length 3.354 by 2 into 10 power 5. 22.36 whole square multiplied with 3.354 by 2 into 10 power 5. What is the value here? Just once again, please check it. This is p square. Don't do with multiplication of only p. And as it is multiplied 0 square, this value will become 0. So this is minus 20 whole square into 3 by 2 into 10, 2 into 10 power 5. 10 square into 1.5 by 2.2 into 2 into 10 power 5. That is AE value is 2 into 10 power 5. 20 square into 3 by 2 into 10 power 5 minus 22.36 whole square into 3.354 by 2 into 10 power 5. So say the values of this p square L by 2 AE individual values. 3.35, that is the length, okay, right. So what is the value of this one? AC. For AC, what is p square L by 2 AE? This is 0. And this value is 3 into 10 power minus 3. Please check this one. Do manually. 3.75 into 10 power minus 4. 3 into 10 power minus 3. 4.192 into 10 power minus 3. So this is total is nothing but sigma p square L by 2 AE. Add everything and tell me the value of this. Please check this whether the answer is accurate or not. Now, after getting this sigma p square L by 2 AE, which is nothing but U is nothing but sigma p square L by 2 AE is equal to 14.759 into 10 power minus 3. Just understand what is the units for energy. For units of energy are nothing but, you know, energy is nothing but, yes, right. So we know that strain energy is equal to work done. Work is nothing but force into distance. Now understand the units of this one. Here the units of p square, that is force square, is nothing but kilonewton square into length is in terms of meter by AE is kilonewtons. So kilonewton one is cancelled. So the units are kilonewton meter. So the strain energy is nothing but 14.759 into 10 power minus 3 kilonewton meter. Now we require deflection at E. Delta E is nothing but 2 into U by W. So 2 into U is nothing but 14.759 into 10 power minus 3 by 14.759 into 10 power minus 3 by W. Work done. Work is nothing but here. At E, a load of 10 kilonewtons is acting. by 10. 14.759 into 10 power minus 3 by 10, which is nothing but what is the unit of this one? Please be consistent with the units. You write it as kilonewton meter. Here load is in terms of kilonewtons. So kilonewton is cancelled and the units are in meters. But deflection we use it to explain in terms of mm. So you have to explain it in terms of mm. So 2.952 into 10 power minus 3 meters. 1 meter is 1000 mm into 1000. So what are the value? This is there into 1000. So 10 power minus 3 into 10 power 3, which is 1 only, which is 2.952 mm. This is the answer. The vertical deflection at E is nothing but 2.952 mm.